Today's lesson will be on parallel lines and perpendicular lines. The first thing we need to talk about is what are the different types of slopes that we may have. One of them is a positive slope. So we're always going left to right. That's positive. We may have a negative slope and we may have a zero slope or one that's undefined. The last two is a horizontal and a vertical line. Slopes of parallel lines, like you see line L2 and L1, slopes of parallel lines will have the same slope, or we say equal slopes. Now in the case of L2 and L1, that is not the case. These are not parallel lines, and you can see this. I'm going to show you right now. So these two lines have different slopes, different negative slopes, and eventually they will intersect. So these are non-examples of parallel. Perpendicular lines are two lines that intersect, but more importantly, they form a 90-degree angles. And the symbol for perpendicular lines is shown right here. It's an upside down T. So it reads, line L1 is perpendicular to line L2, and the slopes will be opposite in value. In other words, one is positive, the other one is negative, and then also reciprocal of each other. So if you have a slope of -3/2, then the other slope is going to be 2/3. So the lesson summary, because it was a very short lesson, the slopes of parallel lines are equal. The slopes of perpendicular lines are opposite reciprocal. Now we're going to check whether two lines are parallel graphically. So I'm going to identify the slope. Both slopes are negative, but they have the same rate of change. So line L1 and L2 are parallel because they have the same slope. And problem number 2, I'm going to do the same thing again, and I'm going to go ahead and construct the rate of change. So I have 2 over 1, 2, 3, 4, 5, 6. So there are the two rate of change. And just by appearances, you can see that they're both going to intersect, and they do not have the same rate of change. So these are not parallel. So what I would say, L1 is not parallel to line. For number 3, we're going to write an equation of the line parallel that contains point C. So what I'm going to do is I'm going to use the slope for number 3. So I know number 3, the slope has to be -2. And I do have a point. I'm going to call that x1, y1. And I'm going to use the point slope formula. So we have y minus y1 equals m times x minus x1. So I have y minus 3 equals -2, because they have the same slope, it's -2, parentheses, x minus 0. So it's y minus 3 equals -2x. And if I want to write it in slope-intercept form, I'm going to have to add 3 to both sides. So you have -2x plus 3. So we started in point-slope form, and we ended up in slope-intercept form. And I did write an equation of a line that contains 3, 0, 3, and is parallel to -2x plus 1. Number 4, we're continuing to write an equation of a line that is parallel to y equals 1/3 x. So the new line would have to have the same slope. In this case, it's 1/3. The point we're going to use is 6, 0. So that's going to be x1, y1. And the formula that we're going to use is called point slope. Y minus y1 equals m, that's a slope, times x minus x1. Now we will just have to substitute. So we have y minus 0 equals 6, parentheses, 6 is the slope. No, I take that back, 6 is not the slope. 1/3 is the slope, parentheses, x minus 6. Y minus 0 is y equals distributive property 1/3 times x, and then you distribute the 1/3 times the 6, so that's going to be -2. So the slope was 1/3. They were both equal. because they're parallel lines. And these two lines will be parallel to each other because they have the same slope. And this is also written in slope-intercept. For this next part of the lesson, I'm still doing example 5 and 6, but I did take away the other examples, just so you're aware. We're still writing an equation that is parallel to this equation. So we have m, and what do we know about parallel lines? They will have equal slope, and the slope will have to be 1/2. We know that this will be a point that's on the new line, so that's x1, y1. So we have y minus y1 equals m. M is the slope of the new line, and we have x minus x1. So we wanted this line to be parallel, so our slope is 1/2. And we also want this line to contain the point -2, 4. So we have y minus 4, and then we have x minus a -2. So you have y minus 4 equals 1/2 x plus 2. And for this example, I'm going to leave it in point slope form. For number 6, we're writing an equation again that is parallel to this equation. So our new line will have to have a slope of -3/2. The point that it has to contain is 6, -2. And the formula we're going to use is the point slope formula to write our equation. So mathematically, we're going to substitute. So we have y minus a -2 equals -3/2 parentheses x minus 6. And you can see I substituted y1 and x1. So now I'm going to leave it in point slope form. So you have y plus 2 equals -3/2 parentheses x minus 6. For exercises 7 and 8, the question is, are lines L1 and L2 perpendicular? Right here, I went ahead and I compared both slopes. One slope is -5/5, which is for L1, and the slope for L2 is 4/5. So you notice for example 7, they're not perpendicular. So L1 is not perpendicular to L2 because the slopes are not opposite reciprocal of each other. For number 8, we're going to do the same thing. I went ahead and described the rate of change for each line. This one is -4/4, and this one is 6/6. Both of them are opposite in value and reciprocal. So we can say that L1 is perpendicular to L2 because the slopes are opposite in value and reciprocal. In this part of the lesson, we're going to write an equation of a line that is perpendicular to the given line that contains P. Once again, this is x1, y1, and we notice that the slope is 2/3. So the slope of the perpendicular line has to be 3/2 and also negative. So the formula that we use is y minus y1 equals m times x minus x1. And we do already have a point, which is 6, 6. So all we have to do is substitute y minus 6 equals -3/2 parentheses x minus 6. And for this part of the lesson, I'm going to leave it in point slope form. The next equation is number 10. We have y equals 1/2 x minus 5. So the perpendicular slope has to be -2. And the point that it has to contain is 4, 0. So the point slope formula is y minus y1 equals m times x minus x1. And that's the point slope formula. All we have to do now is substitute. We have y minus y1 is 0. The slope is -2. And we have x minus 4. So we have y equals, go ahead and do the distributive property. So we have -2x plus 8. And what I did here is I wrote it in slope intercept form. So that concludes the lesson for today. Thank you.